Draft science video. This one on the subject of force, the important subject. This is the whole universe. Yeah, in a way. We're just a pattern in this field of force that everything's made out of. The matter, you could just say, are sticky bits. The protons and the electrons and the neutrons. Neutrons play a role, but it's a role that really just has to do with the balance of the tension between things. So, but we'll get to that eventually. So anyway, this is the simplest drawing of it, just for context, so you understand what the other drawings represent. The universe is this. There's just a bunch of this quanta stuff. All force is made out of this stuff. Anything you call the ton is made out of this stuff. Anything coming off a magnet is made of this stuff. And it's just this stuff at a frequency, or all of one color coming at once, or it being mixed. And it really just has to do with these two things, the electron and the proton, absorbing and emitting this force in different ways. They do it the same way, they just do it from a different perspective, in the sense that the polarization is different. And I'm using color to represent polarization. Alright, so I guess I'll do the talking points first from the notes. So I think these are two adequate sentences to sum it up. Elements of force, quanta, move at a constant speed and in one dimension, and do not carry any momentum from the emitting or transmitting material. So it doesn't matter whether I put force into this camera by hitting it. That means there was force in here when I started moving it. The force was transferred into the camera and the camera starts moving. Doesn't matter whether you're transmitting force or whether you're emitting it, like you start to radiate infrared radiation or even visible light, or reflect it for that matter. So whatever the emitter is doing is irrelevant. It has no effect on what the force is going to do as soon as it's liberated. So the force is doing its own thing, and when it's liberated it has no knowledge of its history, in the sense it carries no information about what I'm doing. Whether I'm moving or not is totally irrelevant to its progress in space. Okay. So in other words, all force covers empty space at the speed of light. So it's the speed of force, the speed of light, same thing. I think it would be better for physics to call it the speed of force, and only has mass in the dimension of movement. So it's one of these little things, and the pointy end is the mass, and that's it. It doesn't have mass going any sideways or up and down. It only has mass where it's going to hit, and everywhere else it's invisible. And you can see that in the fact that we can't see photons, right? Everybody says, well, look at a magnet, they're invisible. It's an invisible force. Well, it's only invisible because we, number one, can't point it at ourselves, and our eyeball can't see the radiation. But the radiation coming off the magnet is just like radiation coming out of a light bulb. It's the same stuff, it's just not in a form our eye can see. Just like ultraviolet light and infrared light. You can't see it. It's going into your eye right now. There's ultraviolet light going into my eye right now. I don't see it. It's invisible. Same thing. No different. Everything's radiating these other forces, quote unquote. And it's just how they radiate them. So the magnetism is going into me, but because of the way I'm configured, it can't make anything interesting happen, because whatever it takes in one place it gives back in another place, because I'm not disproportionately balanced like a magnet. A magnet has a disproportionate balance. That is, if you look at it going this way, everything goes green. You look at it going this way, everything goes blue. And that's what's happening with the force. It's being polarized, and that's being changed into one color coming out one end and one color coming out the other end. and things will react based on that segregation of force, of the arrows of a specific color. Polarization, specific polarization. Color is just being used as a placeholder for the concept of the attribute of polarization. Alright, force cares not about moving frames. So that's another way of just saying it can't carry your momentum. So if I have a magnet and I move the magnet very fast, the magnetic field will be spread over the entire distance of the movement. So it won't be strong, it'll be weak, because each element of it is just an element of it. Over a period of time, the amount of magnetism that'll hit something is reduced because you're spreading the magnetism over a great deal of distance. So each element just flies out and keeps going straight. So if you move the emitter, then you weaken the force because you spread out the force. And the same is true for light or anything else. The force moves straight, and it moves at one speed as soon as it's released. As soon as it's released, it goes. And again, it goes no matter what speed I'm going, it goes its speed and no other speed. And it goes in one direction and no other direction unless it hits something material, the elements of matter, an electron or a proton. Till it hits one of those, it's going forever in the direction it's moving. Alright, so here we get to electrons and protons. Electrons and protons don't move unless you force them with constant acceleration. So electrons and protons are dead pieces of matter. They can't have inertia. So they constantly need to be pushed to go anywhere. And they have to be pushed by arrows of specific polarization, which is magnetism. I think you can understand that. So the blue ones will get pushed okay, by blue, and the red ones will get pushed by red, and the opposite color will do something slightly different. So here's the basics of all energy in the universe. It's this simple. There's only two reactions that take place. One of them is subtle but important. Same color hits same color. So one of these is a force arrow, and one of these is an arrow inside of an electron or a proton. So I guess it's important to say electrons and protons are a collection of quanta moving in the 3 dimensions, and they keep hitting that external pressure I explained before, that field of dense arrows. So that field of dense arrows creates the opposite of a light bulb, in the sense that that dense field, there's always arrows in that dense field that are heading right for me, and all of them are hitting right for me. So they're constantly pushing on me from all directions all the time. And if there's something else next to me, then some of those arrows are going to get interfered with, you can imagine. And there's going to be a change in the pressure between us. And but it's all I need you to understand is the thing that gives me mass, the thing that makes me solid, are the electrons and the protons. They're the things really getting hit by the force. They're the things that are controlling what the reaction to the force is going to be. So you have to understand that they're constantly being bombarded by both red and blue. And there's differences in terms of what happens when certain things happen. Certain amounts of blue will be compressed. So alright, well, let's get to the 2 reactions. So there's 2 reactions. So when a blue force arrow, polarized in the blue direction, hits a blue thing, this is the reaction. And this is the same as true for a red thing. So red on red. So this is the force arrow. Force can't interfere with force. So force can never hit an arrow in the field. It only hits arrows out of the field. So force never interacts with force. No forces can ever combine. They can only combine when they hit electrons and protons and neutrons. That's the only time they can do anything, is they have to hit one of these nuclear bits. But when they hit each other, nothing happens. They don't do that, is probably the better answer, but it doesn't matter. So it's only these ones that are in matter, compressed, that they have a reaction to. And the reaction is when a blue force arrow hits a blue electron arrow, there's a reflection. That is, the arrow inside the electron goes the opposite direction, and the arrow that was going in comes back out. You can look at it the other way around and say they just they just went through each other. But the point is the effect is the same as a pressure. And the point is when you put some of them between an electron, they can't go through the electron, so they keep getting, they're stuck between it. So as the electron moves closer and closer together, any quanta trapped, blue quanta trapped between it will constantly go back and forth. And so you can understand that as they get closer and closer, if this was a bunch of ping pong balls, the ping pong balls would be hitting a lot more impacts. So even though it's the same number of ping pong balls, when they're this far apart, when they're this close, the impacts are larger, which means the force is larger. And so they're pushed apart because the compression creates more force per square inch, if you want to use that kind of analogy. So here's another way of expressing it, but it's a compression. So when these two things move together and these things can't go through, they just bounce back and forth more quickly. And so that creates the repulsive force in nature. The attractive force is just the absence of that force. So the second action, so that's the first action. Same color on same color in matter. So force color on the same color that's matter, we have a reflection. When it's opposite color, that is the force color is the opposite polarization or the different polarization, and those two hit, it's a perpendicular reaction. That is, the interior arrow will go perpendicular and the one coming in goes perpendicular. So you have basically a circumstance now where anything trapped between, any reds trapped between two blues, just end up exiting perpendicularly. So it's like an escape, it's like a relief valve, a pressure valve. So where the pressure is built up with the blues, all the reds leak out. Now this is fundamentally important to gravity, in the sense that once you understand that this is the only mechanism there is, now you say, well, why does gravity not pull as hard as a magnet? Well, the reason is gravity has both these elements in it, both red and blue. So I didn't draw red ones, but proton. So this goes true for the red. So just change the colors, make the balls red, and do the same thing with the arrows except role reverse. So those are the only interactions taking place. This and the two for protons. And that's it. There's nothing else happening. So what happens though with gravity is that you can see that, well, some of the red ones are going to hit protons and some of the red ones are going to hit electrons. And the blue ones coming in, some of the blues will hit blah 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 and blah blah blah. And there's going to be a 50% kind of thing. So 50% of them will get pushed out perpendicularly, 50% will do the reflection thing. And that's happening between the sun and the earth. So the relief valve still exists, and eventually it will all leak out. Is eventually it'll go back and forth, back and forth. So let's say the ping pong ball has to hit a red in the earth to get out, or a red in the sun. And the first time it hits a blue in the sun, bounces. Then it hits a blue on the earth and bounces. Then it hits a blue on the sun again and bounces. It's just a law of averages that eventually it's going to hit a red and then go perpendicular and get out. So eventually the pressure diminishes, but it doesn't diminish as quickly as if you just had all red or all blue. It takes a while because the law of probability is it's going to hit the wrong color just as often as it hits the right color, so it's going to be a lot weaker as a force because it's not strictly polarized. So that's why gravity is weaker than magnetism. Okay. Yeah, so I like that so far. Okay, so back to where we were. So it's important to understand that electrons and protons don't move unless these arrow things push them wherever they're going. So there always has to be force between them to keep them repulsed and to keep them moving towards each other. Like if there was a proton here, you would understand that the proton is allowing, so if it's blue and red, you can see that anything trapped in here, whether it's blue or red, can't bounce too many times, because as soon as it bounces, as soon as the red goes into the blue, it comes out sideways. As soon as the blue goes into the red, it comes out sideways. So you can understand that there's nothing staying between a red and a blue. There's just absolutely nothing that can be kept inside of here to bounce back and forth. They'll all escape. And so anyway, so the external pressure is always going to be greater than the pressure between the two, and that means you're always going to have a tendency to pull these two together. It's really not an attraction, it's just a lack of repulsion. And that's the, I said that in the other video on the other subject, but that's the essence of attraction. The essence of attraction is just the absence of a repulsive element. And so the external repulsive element, the external pressure, wins. Alright, but there's no technical attraction, it's just repulsion. So that tension has to be constantly maintained. So matter, that's not even, when matter's not moving, it's got a lot of force in it creating tension. When you move the matter, that means you've actually put more force in. That means there's more arrows floating around in here, creating even more tension. And the arrows are essentially steered by the configuration of the atomic material. So the more rigid the atomic material, the more rigid the way the force will be transmitted through it, and that's the essence of obtaining velocity and maintaining it, is that your matter is actually energized in the sense that it is full of force. It is filled with this plasma that ends up moving. You can sort of see it in this picture, that you end up with all these perpendiculars, and these perpendiculars can end up just being squares. So the force, in essence, in the matter just ends up cycling. And the same thing is happening inside a magnet, for example. This magnet is pushing a lot of blue out this way. It's pushing green out this way. And the trick is, it's exchanging blue and green in here. So that's the current they talk about, an eddy current. The current is inside the matter, where it's taking the extra blue from this side and shoving it up this way to go out, and it's taking extra green from this side and pushing it out this way to go out this way. So it's refueling from each other's absences, technically. So it's pretty much guaranteeing that anything that comes in, when a blue comes in, it's automatically going to end up going out the blue way, and when a green comes in, it's automatically going to be going out the green way. And that's essentially what a magnet's doing. It's forcing any field arrow that interacts with a magnet gets redirected to a vector consistent with blue coming out here and green coming out here. So even if a green comes in this way, it's going back out that way. If a blue comes in over here, it's going to come out probably in some other vector, but it's always going to be blue radiation coming out of this top and green radiation coming out of the bottom. I hope my camera is moving too much for that, but the green will come out of the bottom, the blue comes out of the top. No matter what comes in from the sides, it all gets directed by this configuration into that, by the force getting directed by the electrons. Alright, I think that's okay too. Alright. Force can be polarized, magnetism, and released at a frequency, light photons. So polarization is what I just explained. The force is moved or migrated by electrons and protons and essentially collected or segregated. The blue goes one way, the green goes another way. Red and blue in the case of this drawing. And that's magnetism, and electricity is created by that. When that force is introduced to a conductor or something else, it pushes the electrons one way and it pushes the protons the other way. Okay, and frequency is just, there's probably lots of ways frequency can be created, so I don't want to get into specifics about what exactly a photon is in terms of how an electron creates one, but I can give you an indication of what I think is going on. Is that I think this energy that's trapped between the electrons, so when two electrons move together, they compress this. And then when they move apart, they don't move apart in a straight line. Electrons don't go away straight. They go away at an angle. That's what happens here. When this red one goes out, it actually converts a blue to an away direction, which seems unintuitive, but it's anyway. And when that takes place, that creates an imbalance. It's going to cause the electron to move away, not at a straight angle. It's not going to go away at that angle. It's going to go away combining the two velocities, the original straight velocity and the new crooked velocity. So anyway, the new imbalance. But I don't want to get into too much. I don't want to get too heavy into that detail because that's more for the subject of that. So anyway, so what I'm arguing is when two electrons are pushed or forced closer than comfortable, there's quite a bit of pressure. Then when they move apart, the electron moves away at an angle, and when it does that, this escapes. So now you have, this is the nature of the frequency, because now the ping pong balls will be released, and they'll be released, they tend to be at the same rate of release because they've been compressed. So they bounce at a similar frequency, or they leave at a certain timing cycle based on the fact that you've compressed them and they're bouncing back and forth. Okay, I think that's an adequate enough way to say it. The point would be is they would have a general separation, and when you compress them, the separation diminishes by exactly the same it's always spread between them. So any compression will compress equally against all of them because of the law of averages. Well, again, that's another technical argument. It has to do with the fact that it's almost like harmonics, that there's a certain measurement that creates where two things can be going at different lengths, but they end up being halves of each other. And so as the thing is compressed, the halves become the same. So at every interval where you have the matching half, those items end up bouncing at exactly the same rate. So even though they were originally at a different distance, once they are halved, they become an equal distance. They have a same common multiple, and eventually you find the common multiple, and then all of them are moving at exactly the same frequency. All right, I know that's getting into more detail than I want to get into. But anyway, I guess the point I would like to make is that I can provide more detail, but the more detail you get into, there's more possibilities of having something a little bit wrong. I'm saying as a general picture, this is general, as a general explanation of why force does what it does, why matter behaves the way it behaves. This generalization fits the evidence. Alright. Force is held in matter as quanta between electrons and protons. So this is the argument again, is that when something's moving, it gains force in a direction, and it somehow maintains the value of that direction, that directionality. So the point would be to recognize is that it gains a bunch of stuff moving in one direction, and it retains it in the sense it doesn't pass through it. It's converted by it, like the magnet does, by creating a current inside of it, so that force ends up affecting more matter going this way. That means it's directed to hit things going this way and to not hit things going this way. So when the force is shot through when the force is moved through the matter, say if I'm moving upward, when the force is pushing up, there's lots of stuff in its way, lots of paddles in the stream. And when the force is going down this way, when it's recycling because it's a current, the matter puts nothing in the way. So it doesn't hit any matter. So it doesn't move any matter. So it doesn't convert any matter. So it doesn't change the position of any of these electrons and protons. So it changes their position going up, doesn't change their position going down. And that's velocity. Alright, I think that's fairly complete enough for now. And I don't know if there's anything. I mean, the frame argument is sort of important to the subjects like time dilation and stuff, because it doesn't. There's no way to escape the connection between force and the constancy of the reality of absolutes regarding speed. Even just the establishment of an absolute speed infers the existence of a zero speed. It would be kind of ludicrous to say I have an absolute speed, but I don't have an unspeed, something that lacks velocity, that everything has to somehow be moving. And there's no rule that everything can't be, something can't be balanced. That is, it can have it at the same number of force arrows going in all three dimensions at one time. There's no rule saying that can't happen, and that that's something standing still. Now, the fact that it's standing still doesn't mean that it's not, all of its little bits aren't vibrating and moving an awful lot, because the field pressure is constantly changing. It's constantly got one extra this or one extra that or something. So there's always jiggling. And the kind of the interesting fact is that it actually might be more chaotic when it is balanced than when it's moving, because then it's less subject to the jiggling, because you've changed the balance. So now it has more force in one direction, which means it's eating up the jitter in one direction more than it's eating up the jigger in the others. And so as a percentage, it's not going to jiggle as much. But I don't. That's another complex thermodynamic type argument. Anyway, yeah. So I think this is good enough for this subject for now. Probably lots to add, but I mean, force covers a lot because everything's affected by it. But the key point here is that I honestly think that this simple fact can explain everything that happens in the universe. That this describes everything. The mere fact that matter is different than free force, and that when the quanta inside of an electron hits field force, if it's blue it reflects, if it's red it exits perpendicularly. And the same rule for protons, except opposite. And that explains the relief valve thing I explained, and it explains the increased pressure when you move things together. And again, the argument would be that this fundamental element of all these physical descriptions of reality that use words like attraction are misidentifying what's happening. Attraction is a lack of repulsion, and that's all. The field pressure takes care of the rest. So anytime you reduce the repulsion between two things, you automatically force them to be attracted, because the field pressure is always constant. Persistently so, unless I'm shadowed by something. Unless there's this big planet right behind me. Anyway, so till the next time and such. I think I've completed my task for this moment in time.